Let's start with net present value, otherwise known as NPV. NPV is defined as the present value of cash flows subsequent to initial investment minus initial investment. Oh my goodness, with all these words, you would think this was defined by an accountant, but it's not. Now, we can make this easier. We could just say that it is the sum of all the present values of the cash flows associated with the project, with negatives being outflows and positives being inflows. And that's mostly how we do this. But I wanted to show you how to manipulate this formula because sometimes in an exam or homework question you will be asked to find the initial investment. And so all we have to do in that case is add initial investment to both sides and subtract NPV from both sides. And when we do, we get this. Notice that I've abbreviated the present value of cash flow subsequent to initial investment simply because it is just so long. All we did was add initial investment to both sides, which canceled with this initial investment, and subtracted net present value from both sides, which canceled this net present value. So we're left with the formula as it is for initial investment. But what if you were asked to find the present value of the cash flows subsequent to the initial investment? So you might be asked, what is the value of this investment after the initial investment? And so how are we going to do that? Well, actually, all we have to do is add initial investment to both sides. And I'm going to also flip it around, as is our normal practice. And so we're left with the present value of cash flow subsequent to initial investment being equal to the net present value plus the initial investment. Now let's talk about the internal rate of return, or IRR. IRR is simply the discount rate needed for NPV to equal 0. Now this sounds fairly simple, and it is. Well, let's go ahead and walk through how we would solve for this thing. We know the definition of NPV, and so all we have to do is set this equal to 0. We can take this one step further. Let's talk about how we're going to go about getting the present value of the cash flows subsequent to initial investment. We know that present value is equal to future value divided by 1 plus r to the t. And so the first cash flow that we have here will be divided by 1 plus r because t is just 1. And we know that the second one will be divided by 1 plus r squared because t is 2. And then we'll go all the way out as far as you want, and the present value of cash flow n will be 1 plus r to the n power. How are we going to solve for this thing? It turns out that this r, that's the discount rate, that's going to be our IRR. But how am I going to get that r by itself? Well, even if you are a mathematical genius, there is no way that you can algebraically solve for that r. And so what do we end up doing instead? It's actually a process called iteration. Iteration is a fancy word for repeated guessing. How can I make this work? Well, we can start out by guessing a value for r. Let's say 10%. And if 0.10 plugged in there for r causes this piece to be less than the initial investment, we know we had guessed too big. So what would we do next? Well, since we guessed too large, let's try guessing smaller. So let's go with 7% or 0.07 here. And this time, initial investment winds up being less than this sum. So what do we do? Well, now we know it's somewhere between 7% and 10%. And we keep guessing and narrowing down on this R until these things are exactly equal. Oh my goodness, such a painful, painful process. But you are so fortunate because your financial calculator is actually a much better and faster guesser than you are. And so I advise you to depend upon your financial calculator for finding IRR instead of attempting to solve it through iteration. Next, we are going to work with Profitability Index, and it is defined as the present value of cash flows subsequent to initial investment divided by initial investment. And keep in mind that initial investment here is a positive number. Many times we think of this as being negative, but in this case it is positive. What can we do here? Well, I recognize some of these things from NPV. And so what we can do is solve this formula for the present value of cash flows subsequent to initial investment, and we can substitute that in up here. So let's do that. So all I did was flip this thing around and add initial investment to both sides, and when I did, the initial investment here canceled out. So what can I do with this now? Well, let's substitute back in. Now let's distribute that bottom term. Notice that these terms cancel out here, and this term just becomes 1. And so we are left with Pi is equal to 1 plus NPV divided by the initial investment.